Welcome everyone to a new video on this Microprocessor 885 lecture series, and in today's video we will learn about DMA, Direct Memory Access. So what is it? A major task in a computer is to transfer data. Now data transferring can be it can happen in many steps, but as of now you know that MUP, IO and memory are connected in such a way that MUP always is in between them while transferring data, because MUP can produce signals like control signals, read bar, write bar. So that suppose your output devices need some data from memory, that data will first come to MUP. So this will reading something from memory, it is MR. Then MUP will send some data to output device, that is IO, right? So just to perform one byte data, 2 machine cycles are needed. 2 machine cycles means it will need some time also. So just to like transferring 1 bit of data, we need some nanoseconds. Obviously in computer they are just very small amount of time. But suppose when you are transferring bunch of data, suppose gigabyte, terabyte, or suppose some much MBs, that time it will slow down your processor. Why? Because it is busy in transferring those data, and as there are software instructions, so that will need some time to perform fetching, decoding and executing. That needs some time. So while we are transferring much data, where processor is not needed to be we don't need the processor, and we have to find some other way to perform the data transfer in a faster way, we can use DMA. What is DMA? Basically when IO devices and memory can communicate directly and they can transfer data. Okay, so how does that happen? In basic structure, MUP system, memory and IO are connected through a system bus. MUP is in the control, he is the bus master. When we want to perform DMAC, we want someone who can tell the MUP that you should stop now and let them communicate. But neither IO devices or memory, they can't produce any signals, any control signals. For that we need someone who can control this process called DMA. For that we use DMAC. DMAC is basically Direct Memory Access Controller. Here I have taken an example of 8237. This is a typical chip that is used in 8085. There are so many more also, but just as per textbook definition, I have also taken this one. What DMAC does, when we need to perform DMA, DMAC produces a signal called hold, which instruct the MUP that you should stay on hold situation now, hold state. MUP will finish the task that it is doing now, obviously, because it is not something damn serious to perform. So MUP, when this produces hold signal, MUP after finishes the current task, it will go on hold state, and MUP will release control over system bus. How does that happen? There is a switch. It's a logical switch, okay? It's not a physical one. Just for the sake of understanding, I'm using this. When MUP goes on hold state, that switch goes down, means that connection get broken. Now this becomes the bus master, and according to this bus master, the only data transfer that will happen now is between IO and memory. Okay, sorry, I've forgotten to tell one step also. When we send hold state and MUP is also ready for DMA, it will produce another signal called HLDA. Okay, so what happens? First DMA says send hold signal, MUP finish its task, send HLDA, hold acknowledgement signal. That switch goes down, connection get broken, DMAC become the bus master, and now data transfer between IO and memory will be performed. Now, as a 5-mark question, this is sufficient, more than sufficient. But the same question comes as a 10-mark question also. For that, you need to write some additional steps also, which are important. Okay. Now, let's take a real life example. Suppose you want to print a PDF of suppose 5,000 pages, and think that maybe that size of that file is how many pages should we take? 5,000 pages. So suppose that file size is of 350 MB. Now 350 MB as a normal student or just from a layman's point of view, that is nothing. 350 MB is it's a small amount of size. But from a programmer's point of view, you know that that is millions of bytes. It will occur at millions of places also. I'm sorry. So how does that happen? It is a bunch of data. It is better to perform DMA here. Suppose in your C drive you have that file. Now I want to print that data. The user sends print. What will happen now? MUP, you will finish your task and then I will perform DMA here. So the first task is, when the programmer clicks that print button, MUP comes in the scene. What it has to do? Just a second. You know that in computers, everything have a unique address. For a layman, this is a file. Okay, that is being stored somewhere in your memory. For a programmer, he or she knew that a file is a collection of bytes. Those bytes will get at its respective addresses. So suppose my 350 MB file, it's stored at maybe the initial address is 4000. Then 1 byte, 1 byte, 1 byte, 1 byte. This is how it will get stored. Let me take a small example. Suppose my file is stored at from 4000 to 4010. When we will perform DMA, the first task is MUP initialize two registers in DMAC. What are they? CAR, current address register, and CWCR, current word count register. Let me explain. When you say I want to print, MUP will initialize these two registers. How? In CAR, it will store 4000, the initial address, and at CWCR, it will store that count. How many places in the file consumes how many boxes? 10. So CWCR will be 10. Now, when it will print that file, what will happen? First page, I am at 4000. Print. Count goes at 9. It will increment, come to 4001. Print this page. Count goes 8. Come to next page. 4002. Print goes at 7. This is how it will continue till 4010 until counts become 1. So what is the difference between DMA and normal data transfer? In data transfer, they all are software instruction. This is why they will need some more time. The main time that is being captured there is that fetching, decoding, and executing. Executing is the last process. Don't take this in mind now. Main time is taken for fetching and decoding. But here we are just incrementing and decrementing. It's just like how a counter performs. So this is why DMA don't take that extra time, and it is tremendously fast. You understand? So first step is MUP initializes address of CAR and CWCR. mu p initialize CAR and CWCR. Next step, when your computer starts, suppose you are you're having a printer also. Printer also turns on when you start your device. Means the peripheral devices that are connected to your computer, they also get starts when you power on your machine. But then they goes on sleeping mode because you want to save power, right? But by default those output devices are active. Now suppose in some case you want to print a file but you don't have a computer, then it will stop you, right? That you can't perform DMA here. For that process we have something, we have another facility also here. What is it? After MUP initialize those addresses, these IO devices have to produce a signal called DREQ. DREQ stands for data request. If DREQ equals to 1 means my IO devices are ready. You can perform DMA. If it is 0, then obviously you don't have output devices, so how can you transfer data between memory and IO? So for next step is DREQ. Third, what is next? DREQ. Third, I'm just writing this in order just to help you in your exams, okay? Third, now my DMAC is ready for DMA. So DMAC will now give a signal to MUP that hey, you can now you should stop what you are doing. I mean finish your current task and then help me doing my DMA. So DMAC will now produce hold signal. When MUP gets this hold signal, MUP will finish its current task, because obviously it is not something that much important that MUP has to stop what it is doing right now and go to execute it. It will finish its current task. Then MUP will produce HLDA signal. You know what is HLDA, right? Hold acknowledgement. Means okay, I haven't finished my task, you can perform DMA right now. After MUP sends HLDA command, now who is in control? DMAC. Means DMAC will now works as a bus master. Okay. After DMAC become DMAC is in now DMAC will produce another signal to the IO, which is DACK bar, which is data acknowledgement bar. Means DMAC is just telling the IO that okay, now I get the permission to perform DMA. Now you guys can transfer data. Okay. So what is the next step? Your DMAC gives DACK signal. Okay. 7. Now data transfer is being started. Means that bus, you remember, that bus will get disconnected and the IO devices and memory can transfer data. How it will happen? You remember that initial address? That initial address will get incremented until the count becomes 0. When the counts become 0 means your whole file is being transferred. Data transfer ends. So in 7th step, data transfer happens. And on the last step, when the whole data transfer is being performed, now DMAC can say that okay, MUP, now you can get back to your work. I have done my task. For that HLDA, you remember this HLDA? Sorry, you remember this whole instruction which becomes 1 to make the MUP at hold state. Now DMSA will make this whole instruction as 0. It will set hold as 0, and now MUP is free again to transfer data. In these steps, DMA will be performed. I hope you understood. The last topic that I am to discuss is what are the types or methods of DMA. First one is block transfer. Till this last 15 to 20 minutes, whatever we have discussed is the example of block transfer. Means when we are transferring that whole bunch of data once at a time and keep our MUP on hold state. This is when block transfer, this is the example of block transfer. What are the pros and cons? In block transfer method, it's tremendously fast. Okay, just because now MUP is on hold state and TMS is in control, IO and memory can transfer data. But the drawback is MUP is on hold state. Means when your file is being transferred, you can't do anything else. Means suppose you're copying a file from mobile to phone, you're copying suppose a film of 2.2 GB. When you're copying that file for that 1 minute, it is very fast in transferring that data, but on that time you can't perform anything else and you have to just stare at that copying file. Okay, so this is the example of block transfer. Second is cycle stealing or one byte transfer. The name suggests it's one byte transfer. What happens here is, this is your MUP, this is your DMAC. MUP will perform one machine cycle, 1 byte for MUP. Second machine cycle, it will be for DMAC, 1 byte for DMAC. You know, this sounds silly, but I will just give you an example and you can understand what is it. Nowadays, processor use this method of file transferring, mean in DMA, that cycle stealing. You have seen that suppose when you are copying something, suppose a film, you see that those curves are occurring, copying 0%, 5%, 10%, 90%, and then there are some waves. You remember that one? You know what happened then? Suppose these are your DMA cycles and these are your processor cycles. When you are copying that file, means you are performing DMA, but it is in cycle stealing method. Means one cycle for processor, next byte, 1 byte for processor, next byte for DMA. 1 byte per processor, next byte for DMA. 1 byte per processor, next byte for DMA. Processor, DMA. They are going continuously, means they are producing a wave. What is happening here? It is just like block transferring method, but in block transfer method it may take 1 minute, but it is you can't perform something else. Your MUP is whole state. But in cycle stealing method, it may take 2 minutes, but within that time you can perform some other operations also. Okay, so what is happening? 1 byte for machines DMA, next byte for MUP, again DMA, again MUP. So your MUP is not exactly on hold state. You can do something else also in that time. Third one is demand transfer. You remember that DREQ signal, right? When we are performing just normal DMA, we just need that DREQ for once when you are starting that operation. But in demand transfer, means it needs that DREQ needs to always say that I need this transfer. So that signal continuously DREQ shows that it is 1. So this the output or IO devices, they just want that data. So when we, like our name, as the name suggests, when the file transfer is being on demand, then we use this method. The last one is, I didn't write this because it is not a part of 8085, but it's just in general, this is a very useful method, which is hidden mode. In hidden mode, what happens? DMA will be performed only when your MUP is idle. Okay, just for give me an example, like suppose you're writing something on your laptop. Okay, someone calls you and you just stop typing and then talk to him. You come back after 5 minutes. For those 5 minutes, your MUP is idle. 5 minutes means 300 seconds. 300 seconds. Within those 300 seconds, MUP can perform billions of operations. They are so fast. So what has happened right now? For those 5 minutes, your MUP is idle. Now, hidden mode gives this flexibility that in that time, your DMA will get performed. Just like when you are downloading some file from internet, and there is this facility that when nobody is using that internet, only then download my file, so that no one else is get affected by slow internet. So hidden mode is when MUP is idle, DMA will get performed. This was it for today. So I hope you understand what are the steps required in DMA. First, when you want to transfer that data between IO and memory, first MUP initializes addresses of CAR and CWCR. Next, DREQ sets on 1, any output devices says that I'm ready. Third, DMSA will produce that hold signal that MUP go on hold state right now. Next step, MUP finishes the current work and gets on hold state. Next step, MUP produces hold acknowledgement signal just to signify that okay, I am on hold state right now, you can perform DMA. Third, DMAC is in control, it will perform the data transfer. For DMA is in control, and next step is DMA now produce DACK bar signal just to signify that now I am in control, so IO devices can start data transferring. Next is data transfer starts, then DMSA will produce DMSA will set HOLD hold signal at 0 and tell that now it is being free, and MUP can perform the task that it was. So this is how DMA is being performed. I hope you understood. If you have any problem, please ask me in the comment section, and thanks for watching. All the best.